Welcome Year 9s. We're going to look in this video at exercise 2a and 2b. The first one, exercise 2a, is on creating or constructing algebraic expressions. So I'm just going to whip through some and I've set you some different ones to do, and if you have any questions you can let me know on ThinkWave about those, and if necessary I can give you more help on those. So I'm going to start off with looking at the square question here, 1a. Now I know that a square has 4 sides and the sides are all equal. So if I'm doing the perimeter of the shape, I would say that the perimeter is going to be equal to a plus a plus a plus a, or alternatively a simple way of writing that would be 4a. And then we could use substitution in part 2. And I'm just going to do 2a here. If a is 5 centimeters, then the perimeter in that case would be 4. And if a is 5, it would be 4 lots of 5, or 4 times 5, which gives us a perimeter of 20. So that's that question. Question 3a. We've got to derive a formula for the perimeter P for each rectangle. Now, I notice on my rectangle, I'll just draw a bigger version of it here. Just imagine those are all straight lines. I've got B here and L here. Now, clearly, I hope you can see that I've got a B here, then this must also be B. And if I've got an L here, then this also must be L. So then I could write my perimeter. Perimeter equals, why am I writing in red pen? Perimeter equals B plus B plus L plus L. Now, we like to write things in an elegant fashion in math, so we're going to say, well, I've got 2 B's plus I've got 2 L's. So that would be my answer there. Okay, I'll move right on to question 7a. 7a, I have got to simplify 3x plus 2x. What this means is I've got here, this would be x plus x plus x. And this one would be, and then we've got this plus here, so this is that plus here, plus, and then 2x is x plus x. So you can see that altogether we've got 5x. 3x plus 2x is therefore 5x. Right, I think that's probably all I will do from that exercise. And now I'm just going to go on to using indices in algebra. Now, we have already done indices with numbers, so this is just a very small extension of what we learnt last week. So I'm going to write out my question, which is what you should be doing when you're doing these. A squared multiplied by a cubed. This is 1a. And my next line, I will write equals in this manner. And remember the index rule. When we have a multiplication, when we have multiplication here, that means we're going to add the indices. So I would write a to the power of 5, since 2 plus 3 is 5. And be careful to make sure that you've checked that your bases are the same. The bases here are both a's, so I can add the indices. Let's move on. I'm going to try 1e with you. So we have p multiplied by p squared multiplied by p to the power of 5. Now, the thing to recognize is that, p here is actually p to the power of 1. So when I go to add these all together, I'm going to go 1 plus 2, which is 3, plus 5. So I'm going to have p p to the power of 8. Alrighty. Now, the last one, some of you might have wondered how to do something like this, that I'm going to do from number 1 will be 1i. And our question here is m to the power of a times m to the power of b times m to the power of c. Now, we're just going to write m to the power of a plus b plus c. And that's our final answer. We can't simplify it any further than that. Now we're going to move on to using our division index rule. So the first example I have here is 2a, q squared divided by q. Now remember that this here, this q, is actually q to the power of 1. So our final answer is q to the power of 2 minus 1, which is q to the power of 1, or in other words, q. I'm now going to try something slightly more difficult. I'm moving on to 2e. The question here is 6, if I can read this, it's a bit small for me, 6x to the power of 6 divided by 2x to the power of 2. In this case, you'll notice that we have what is called a coefficient in front of each letter. The coefficient is the number in front of the letter. So my first step is to simplify that. 6 divided by 2 is 3. Now I look at my letters. I've got an x to the power of 6 divided by an x to the power of 2. I use my usual division index rule. So it's going to be x to the power of, what is 6 minus 2? That is 4. So I have 3x to the power of 4. That looks a bit messy. There we go. All right. I could use the same sort of logic in 2g. With 2g, I have 10n to the power of 6 all over 2n to the power of 3. Again, we work with the coefficients first. So 10 divided by 2 is 5. N to the power of 6 divided by n to the power of 3 is n to the power of 6 minus 3, which is 3. All right. We're going to move on to question 3a now. In 3a, I'm given 2a to the power of 3 multiplied by 4a to the power of 4. I first of all am going to deal with my coefficients. So my coefficients are 2 and 4, and I'm multiplying them. So 2 times 4 is 8, so I write 8. Then I look at my letters. I've got a cubed times a to the power of 4. So I add the indices because I'm multiplying and the base is the same. So it will be a to the power of 7. Right. Now, I'm going to move over to 4a. So we'll do that here. 4a. I've got x cubed bracketed and x squared bracketed with a cube on the outside. Now what this actually means, I can simplify it as they've asked me to do, is x squared, and I'm just going to do a dot for times because it's going to get confusing otherwise, times x squared times x squared. And then we add all of those x's, those 2's together, 2 plus 2 plus 2, which is 6. Now what you will notice, I hope, is that 2 times 3 is 6. So that is the shortcut method when we've got a bracket. So let's try one more. Let's try f, 4f. So with 4f, we're going to have a bracket 3x squared all to the power of 4. My next line is, well, that means 3x squared times 3x squared times 3x squared, times 3x squared. Now, let's do our coefficients. We've got 3 times 3 times 3 times 3, which is 3 to the power of 4. Well, you know that 3 times 3 is 9, times 3 is 27, times 3 is 81. And then we just add our indices, or we could multiply 4 by 2. So we should have 81x to the power of 8. Gee, that is not very pretty. That's a bit better. Okay, there we go. Now I'm going to do a couple more to help you. Let's do 6a. X squared multiplied by x to the minus 3 multiplied by x to the 4. Now we're just going to use our index rules. We add all the numbers together. I'm going to add all my positive numbers first. I've got 2 and 4, which is 6. And then I'm going to add minus 3. 6 plus minus 3 is simply 3. So overall, I've got x to the 3. Number 7a, writing with a positive index. Now, I'm given p to the minus 5. Oh, goodness gracious me. P to the minus 5. Like so. And I remember, because I was listening, that that is the same as 1 over p to the power of 5. So, remember from last week how to convert negative to positive indices. I'm going to do one of the more challenging questions that I gave to you. I think I might do number 13h. Yes, I did mean 13h, not 12h. So here we go, 13h. What have we got here? We have h in bracket h to the power of 8 all over h squared to the power of 2 multiplied by h to the power of 3. So remember, we must work inside the brackets first because, goodness gracious me, because the rule is brackets first, BEDMAS, okay? So inside the brackets, I've got h to the power of 8 divided by h to the power of 2. I'm going to use my division index rule, the same base. So we subtract the indices. 8 minus 2 gives us 6, and that's going to be squared times h to the power of 3. Now, BEDMAS, so the second thing is going to be e exponents. So we're going to go h to the power of 6 squared, which gives us h to the power of 12. And we're going to multiply that by h to the power of 3. Our final line is going to be h to the power of 12 plus 3, or h to the power of 15. Well, I hope this has been helpful to you in reviewing some of your index rules, and also perhaps reviewing how to make expressions in algebra. Do make sure that you let me know on ThinkWave if you're having trouble with any particular questions so that I can assist you. Alright guys, see you next time.